Well, world, hello, as Yoda would say. Listen to the rest of this stream, you must. Fused VR team coming at you. I'm Hassan, Fused Man here. Today we're going to be prototyping how to build the Force using a grab mechanic in virtual reality. Hassan's going to pop in there and try it out right now. It's going to be a pretty fun one. There's a lot of design questions, lots of work around physics and stuff like that.
And I didn't restart it.
Yeah, it looks like we need to restart this
Oh, there we
thing.
go.
Oh,
Okay.
we got it working. Yeah, so you can grab and throw objects with both of your hands. Abdo has modeled some gloves for us. So it's going to be a fun time just talking about the design of how the Force works and how we can get it started. We also have some awesome news this week. So Vasant, you want to talk about that? Looks like he's training his Force powers right now.
I almost chopped my head off. But yeah, so this is what we're building, and I figured out why it's happening. It's because I'm assuming you use specific IDs for the controllers.
Mm-hmm.
So I think it actually used the mixed reality controller as one of the IDs.
Right.
Which is why like one controller worked, the other didn't. All right, so I'm going to switch to this guy and this guy. So yeah, so if you didn't see the news on social, Hayden, who's been on the channel for a long time, is actually launching a game called Mech Skeleton. It's basically a mech runner, and I think this story is super inspirational. And if you're building content, I definitely recommend reading this. And if someone with disabilities can do it, you can too. It's a really great story, and props to him for putting something out there. We're working on something ourselves, but it just takes time, and just putting something out there is really amazing.
Yeah, totally. And if anyone else out there is building some stuff, even if it's prototype level and you want to share it, let us know. I mean, we're definitely happy to try stuff out and also spread the word about anything you're working on with our streams or anything else. It's so exciting for us to see you all building.
Yeah. This one I believe is coming out on the 21st, so go check it out when it comes out. I'm excited to try it out. And with that, want to take it away?
Let's get started.
There you go.
All right, cool. So I'm actually going to close out this project. As usual, we'll start from scratch. So let me pop up in Unity.
There you go.
Create a new project. We'll call this the Force. And today, again, we're going to be doing a Force grab mechanic. So you can grab objects at a distance, move them closer, move them back, throw them, rotate them, and so on. There's other aspects of the Force too. You can bet that we're going to be looking into creating lightsabers, Force pushes, and tons of other stuff in coming weeks. And if there's other things that you want, let us know. Alright, so as usual, let's go to the asset store and let's make the scene VR ready. Look up the Steam VR plugin. Let's grab that thing. Import it into the project. And at a high level, just a breakdown of how the project is going to go. First, we're going to make it so that we can click and point to objects using our controllers. Then after that, we're going to deal with some of the physics and mechanics of moving objects around. And if there's any time left for a third piece, we'll just mess around with maybe some ragdolls or other stuff like that. So this is still importing. Also, we're hoping to see plenty of Force and Star Wars related sayings in the chat today. FuseMan will be in there, so keep them coming.
There we go.
I actually wrote down some that I'm going to try to work in. Let's see if there's any. Oh, actually, I will work them in because when it comes to that,
I didn't even see this.
It's all about do or do not. There is no try. So I will be sure to work in all the quotes. We can cross that one off.
I'll get a pen. We're not like probably the hugest Star Wars fans in the world, but
still
we can appreciate it.
Yeah, definitely.
All right, I'm almost officially in the chat.
Okay, so I'm going ahead and just adding in the camera rig. We need something to stand on, so let's create a plane here. And eventually we're going to want some cubes or just some things to throw around, but we'll wait on that. One thing that I want to add in right now though is, well, first of all, let's save this scene as, we'll call it force grab, since that's what we'll be implementing today. And one thing that I actually want to add already is going to be a material to this plane. FusedVR and I were watching just a few postmortems recently, and one really cool point that I saw in a postmortem was that it's important to always add at least some sort of material or texture to your objects in VR, because in the real world, everything has at least some kind of a texture. Like, most things are not just flat one color, they'll at least have some shininess or some blemishes. So let's look up just some basic materials that we can apply. Of course, we can find something free. I like this industrial material pack. And once we put this on the plane and even our cubes, it automatically makes things feel a little bit more legit and real. Finally got this thing in here. Thanks for being patient, everybody. So, as I was saying before, it's just nice to be able to put materials on just anything that you're using. So let's just slap on a concrete material and let's get started with building this thing out. So first of all, let's scale up this plane so that we have more space. And now we're going to get into the first part, which is being able to click out and select objects.
We got a quote in the chat.
Yeah?
Use the source, Luke.
use the source?
Yeah. Source
like source code?
Yeah.
Oh,
what did you
nice.
think?
I like that. Well, I was thinking of use the force.
Exactly.
But source is a really good play on that. Plus, thumbs up to whoever came up with that.
Joe.
Cool. All right, so we're going to be implementing this force grab script on the left and the right hand. So let's create a script for that. Go ahead and pop that open. And at first, I mean, we just have the boilerplate of, like, we need to get the controller and the controller device so that we can get access to the buttons. So I'm going to make a Steam VR controller device. This is going to store a reference to the controller that we're attached to. And in the start method, well, there's a few steps that we're going to do here. So first we need to get the tracked object of this hand. That's just a simple get component. Steam VR tracked object. And then next we actually want to get a reference to the controller, which is pretty simple. Just Steam VR controller dot input. And we use the index of the tracked object. Okay, so now we have access to the controller that we're using. Might have a brace problem here. Oh, nope, looks good. What we can do next is actually draw the line to an object that we're trying to select with the force. So to do that, let's first add in a cube that we'll be selecting with the force. There's a cube. Throw a material on this thing. This green one looks kind of interesting. It's not very realistic. This one makes it look more like a crate. I like that. Or I guess we could go with the stone one. Now let's go with the crate type box.
Nice.
And basically here we're going to cast out a ray. We're going to do a ray cast from the controller to the cube or whatever we're trying to pick up. So we need to put a rigid body on this thing. It already has the collider. The rigid body is going to make it so that later on we can use physics on this thing pretty easily. So here we'll just have something called raycast for grabbable object. And let's make a method for that. And what we need to do is we need to come up with we need to create a raycast hit that's going to store the result of whatever this raycast hits, and we also need to make an array that signifies where this raycast is going to go. So we can just use, I think the parameters to this are the controller, the position that we want to start from for the ray, and then the direction. So we'll just use a transform.position because this will be attached to the controller, and then transform.forward works. Okay, so now we actually do the raycast. And we give it a few different arguments. We can give it the ray that we just defined, the hit, we do the out hit key so that we populate hit with whatever the result is, and then we can also define, I believe the third one would be the maximum, or like the ray length. So we can just do mathf.infinity so that it goes out forever. And then if that hits something, this statement will be true. And so just to test that out and make sure that we're hitting these objects, we'll print hit. So that should be just about ready to go. We just need to attach that to both of our hands, and then we'll be able to see if this is working to detect that object. Then we can actually make this work. Oh, looks like we got some compile errors. Let's see, force grab, there's a semicolon area somewhere. My favorite. Input. Get component. That's weird. Oh, I see. Alright, yeah. Easy fix there. So our errors are gone. This is basically like the Padawan level of force training. You guys should be thinking about whether or not you want to be good or evil. We'll use the dark side or the light side of the force.
We need to get some lightsabers in there.
Yeah.
that color is color can be powerful.
All right. So here's my controller. Let's pop up the console so we can see when we're hitting this thing. So I'm pointing at it now, and I do see that hit pop up, or at least I see it pop up one time. Not quite sure if that was... Oh, that's a hit from when it hit the ground, maybe.
Joe's going for the light side.
Nice. So let's see, it looks like there might be a bug there. Raycast.
Are you light side or dark side?
Well, I took a quiz one time, and the quiz told me that I was Darth Vader. Like it was a what character are you? So I think this third argument is actually no, it should be.
Robert's suggesting to do a debug ray on the raycast.
Yeah, that's a good call. Dot. See, so start, and then direction. So this will show us, at least in the scene view. So it's pointing in the right direction. What I'm gonna do is make it so that as long as we're hitting it, we print hit, and then else we'll print no hit. We should get a bunch of hits. Alright. Oh, okay. I see what's going on. So there's folding going on these the console messages. So if you see the number popping up right there, there's not hit, and it's printing tons of times. And when I point there, hit is also printing tons of times. So that's working as expected. What I was confused by is that we have the messages folding into one line rather than printing and like so collapsing basically. Alright, so we're pointing to it, we're detecting it with the raycast. Good call on the debug ray, that's a great way to debug raycasts. Now let's actually draw that line. So to do that we're going to use a line render. Line renders are, whoops, opened up OBS. Line renders are pretty solid just for, as they say, like drawing lines. But it's really cool when you're doing it with more than just 2 points. We're only going to be doing 2 points today. But you can actually draw like curves and stuff like that. So they're pretty awesome. Add one to both of these. And the way that a line render works, as I said before, is you specify the points and you also put a material for the line that you're going to draw. So for our material, we'll just use something that's straightforward. So let's see, just throw in this, whatever this like rusty material is. We're going to make it so small by changing the width that it doesn't really matter. And you can actually already see the materials right here. So even 0.1 is too big. Let's make it 0.01 so that it's just like a bullet line pretty much. And then we want to access that in our force grab. So let's make a variable for it.
Not sure if the stream is hearing the dog in the background.
Yeah, there's a dog in the background. Hopefully that thing gets some help.
Oh.
So now we have a reference to this line renderer, and what we'll do is, let's see, what's the best way to do this? So here we want to update its positions when we actually like are selecting an object, and when we're not able to select an object, we want this thing to disappear. So to make it simple, what it could look like is we could create a vector3 array. We'll call this positions, and that's new. We're going to make sure that has 2 points for the start and the end. In the first, we would put the transform's position. Again, that's where our hand is. In the second, we'll put the point of the hit. And then to actually change the line renderer, you can just access that variable and use set positions and pass in the vector3 array. So now, as long as we're pointing at something, we should see this line render drawing. Confirm that that works. Oh, so I didn't adjust this one. We'll need to fix it. But the line render on this should just be like a red line. Once it gets detected, at least. Oh, there we go. So you see that it's only moving when I'm on the object, and then when I move away, it actually kind of stutters. So what we want to do is actually disable the line render when we're not on the object itself. There's also an inefficiency in this code right now. So if you look at it, every time we're making new positions for the line renderer, and that's just not efficient. So what we can do that's, just better code style is let's create a vector3 array that we're going to use globally. We'll call it positions, and then instead of instantiating a new array every time, we'll just update this one. So in start, let's first of all instantiate that and declare that it has 2 slots. And then here we can abstract this code out so that it's a little less messy. We'll call it display line, and it will take 2 arguments. First, we'll make it have whether or not we want to display this line renderer, and then for the second argument, let's give it the endpoint that we want to use. We're not giving it the starting point because the starting point is basically always the same. We're going to access it by using transform.position. So we can get rid of this line, move this into there. To start off, we can say line renderer enabled is equal to display, so that's either true or false. And then here, instead of hit that point, we'll use endpoint. So now, if we get a successful raycast, we'd call display line with true and hit that point. If we don't get one, we'll call display line with false. And there we could just use like transform.position as the endpoint. It's not going to show up anyway, but you know, even if it was to draw, that would just be drawing a line between one point and another, so the line wouldn't really appear. So that should work fine. Let's also update this other line renderer so that it doesn't draw this like pink material can't be accessed type of image. So let's copy this component, go over to the left line renderer, and paste those values. So now both of the controllers are using the same material for the line renderer. And we should only get that line showing up as long as we're pointing at an object. So let's see. So it's working on the ground right now. That's because the ground has a collider on it. But it's also working the way that we want on this cube. And we'll make it not work for the ground later when we actually implement what we need on this box so that we can throw it around. Alright, so that's pretty much the first part. I mean, now we're going to actually get into grabbing this object. But definitely if there are any questions so far, we should talk about them. Has anything popped up in the chat?
So someone, let me find it, had asked for something more like a spring-like mechanic, which I think you'll probably cover later.
Yeah.
But I would imagine that's based on like distance of like, the closer it is, the more force you have, pull you have, and then the further away it is from your hand.
Oh, that's a good way of doing it. No, so we don't have it done like that so far. It's actually pretty universally mapped so that you'll have like you guys will see it later, but basically by the time you grab something and pull it to your body, it will come like right up to your face as opposed to being far away. So there's no distinction really between how far it is and how much force you have. We scale it always so that no matter how far it is, when you pull it, it comes all the way next to you. But that's a really good idea for something to implement. We can definitely talk about that and explore it later. I like that concept a lot.
Yeah, the other thing is people are excited to see a ragdoll.
Yeah, hopefully we can get to that. I'm definitely stoked about it.
And then other than that, I think we're good. So someone's asking about a 3D graph calculator, and then another one, and then other people are talking about the conference.
Oh, nice. Wait, the SVVR one or
different
one? Nice, nice.
Few people are going.
Definitely come to the conference. Say hi to us.
We'll be there.
Alright, cool. So let's keep moving with this. So next part of what we're going to do is actually breaking down what happens when we click on a movable object and how we get it to move around. Also how we're implementing the force. So what we first need to do is actually stub out our controller button like framework. So what we're going to be doing on each type of button press. To summarize, when we click on something, we're going to want to pick it up. When we hold it down, we want to move around, and when we let go, we want to drop the object. So we can stub that out inside of update right now. So it's Steam. Oh, it's actually controller dot get press down. So when the trigger's pressed, we'll grab something.
And then one other thing, Robert's recommending later, and there's a link in the chat for it using lightning to come out of the, out of the glove.
Yeah, that's pretty cool. I like that idea.
I'll make sure to save that link.
So here we're just rigging up again the stubs for pressing it, holding it down, and then letting go. Last one is letting go. Okay, press up and trigger. So here will be force grab. This will be force move. And this would be release. So let's see. What to do first? I guess the easiest one to show is probably just doing the force grab at first. So what we're going to want to do is access the object and actually turn it to kinematic so that we can control it via scripting rather than having it being controlled via gravity and Unity like physics simulations.
There's a question from Joe, arrays versus generic lists. I know generics are syntactic sugar, but does one translate better than another in the final code? I don't know what you're using right now, actually.
Well, right now we're using arrays because we are working, we're just trying to play nicely with the line renderer's set positions, and it takes an array. So I guess you could probably use something else and convert it over, but here, we have a very array-friendly problem, which is we know that it's always going to be of size 2, it's always going to be a vector 3, so an array works pretty well. Alright, so yeah, let's get started on this. And actually, this is a good time to start creating our grabbable item. Is there more questions?
No, not right now.
Okay, cool. So we'll create a script on this cube. This will represent something that we can grab with the force. We'll just call it grab item. And here, we actually need to adjust this. So what we'll make this do is we're going to raycast for that grabbable object, and if we can get a grabbable object, we're going to return it so that we can use it when we're grabbing, moving, and releasing the object. So we'll change this to return one of these grab items, and we'll also change the way that this if statement works. So not only do we need to get a successful raycast to something that has a collider on it, but we also need the object that we get to have a grab item attached to it. So we can access the game object through the hits collider, and then from there we can check if it has a grab item component. We want to make sure that that is not null. And in that case, we'll just return the value of this. Otherwise, we'll return null. And what that does for us up here is that now we can capture what is returned from this raycast and use it for our force functions. So I'm going to create another variable that we'll be able to have access to throughout the program. We'll call this grabbable, and we'll store it right here. Now, if we don't get a grabbable, we don't really need to do the rest of this update function. So let's write in some code to skip that. That's just a small optimization, and will also make the rest of the code easier to write. So if there's no grabbable, just do a return. And last part is that we only want to do this raycast if we haven't grabbed something. So we can actually add that in later. For now, let's just work on doing this actual force grab. So for starters, let's take this grabbable, and we're going to have a method called, guess we'll call it, let's just call it grab. And it will take one argument, at least so far, that says whether or not we're grabbing or releasing this object. So we need to implement that in grab item. Here we are. Call that grab. It takes a boolean that says whether or not we should grab. And like I said before, when we're grabbing something, we want to turn its rigid body kinematic so that we can control it in its motion via scripts rather than Unity physics. So to do that in the grab item, we need access to the rigid body. We can do that with the start function. Get component, rigid body. Ooh, I'm not doing so well on the Star Wars quotes anymore. Let's see. Oh, add a rigid body you must. Boom, got it. That's not a quote.
Did that one.
Did I say that one?
You did it at the beginning.
All right, fine. How about oh, gosh, I think that I've actually done most of these.
Rough.
There's remember, your focus determines your reality. I guess that I'm focused so much on the code that I'm not focused on Star Wars. I don't know.
I think that's a stretch.
I need some Star Wars quotes. Give me ones to work in. Or if someone out there, if you're kind enough to tell us that you love us, we'll respond by saying we know. So hopefully someone out there gets that reference. Alright, jumping back to the code. So let's just set this rigid body's kinematic to the value of should grab. So if we should grab it, we make it kinematic. If we shouldn't grab it, then we make it non-kinematic. So we can actually test that out right now just using the grab and release. So I'll go over here. And there's a proof of concept for this. I'm going to lock the inspector on the cube. And what we want to happen is that when I click the trigger, this is kinematic should be checked. And when I release it, it should get unchecked. So there's my controller. Pointing, I'm about to click. You see that it becomes as kinematic, and then when I release, it gets unchecked. So that's the start to grabbing this object. Later we actually have to apply the move. Now one thing that I also want to note is that like when we have actually grabbed and ungrabbed this object, because we only want to be doing this raycast for more grabbable objects if we haven't grabbed something. So grabbed would be true in this case, and it would be false in this case. And you guys are probably wondering, I mean, grabbed, where did that come from? Yeah, it's a variable that I haven't created yet. So I'm going to go up to the top.
Yeah, someone was asking about the implementing the graph mechanic, but yeah, I think you're covering it.
Yeah, so
Which no one's heard.
Yeah, there we go with starting grab, and so we only look for a grabbable if nothing has been grabbed with this hand already. And then within this if, we only continue with this function if we end up finding something that's grabbable. Okay, so we have those going. I mean, we might as well move on to move now. Let me think if there's anything that we're missing so far. Doesn't really look like it. We're actually at almost time for the break. When do we do? 10:50 or?
Somewhere around there, 10:50 to 11.
Okay. Let's see. So, yeah, I mean, just to give an overview of this, we have a bunch of variables at the top that we're using to keep track of the line renderer, the controller, really most of this stuff, it's a lot of boilerplate type of things. I mean, that's I think the cool thing about Unity. I mean, you can implement some really cool mechanics just using some stuff that you can reuse in lots of other projects. So we've been doing tons of raycasting in other projects too, and here it is again. So all of this, it should be stuff that we've covered in last streams, but if it doesn't make sense or if you're tuning in for the first time, just let us know if you want us to go in more depth on anything, and we definitely can. But for now, let's get to actually moving this thing around. So here, we're not going to be using update. So in grab item, we'll get rid of that. And this is actually a good point to start the design discussion of how you could implement the force. So going back to the point of this coffee cup, let me see if there's anything better. I have a pen here. So assuming this pen, the way that we're going to do it is that as I move my hand, it moves around rather than staying locked in place and rotating as I rotate my hand. And also, we're going to basically be scaling up the movement of our hand to the movement of the pen. So based on how far away it is, if I move my hand just forward a little bit, it's going to move back very far. And then I guess the inverse of that is that once I move my hand close to myself, we're going to reel it all the way in. So we're just scaling up the movement on the grabbed object based on how much our hand has moved. So if I move forward a bit, we're going to scale up and move forward the pen. If I move back, we're going to scale it so that it comes all the way back to me. And we'll be doing not a similar thing with rotations because it doesn't really make sense. I mean, if we rotate our hand a little bit, ideally the pen will rotate the same amount. It's really just the push and pull that are, kind of complicated exactly how you want to implement that. So let's get started with doing that. We're going to create a move function on the grab item, and this is going to take a few things. I mean, eventually it's going to take a bunch of information around position and rotation, but we're just going to start with position for right now. So what it will take is a vector 3 that represents the current, I guess we'll say current hand position. A different vector 3 that's the last hand position. And again, we're going to be scaling up between these two to apply the motion to the object itself. So we can go ahead and implement that here. What we'll need to do is keep track as a result of what our last position was and what our current position is. So those, I think, will be our last global variables. I mean, usually you want to keep these to a minimum. So I don't think that we'll need any more beyond these two. So let's create a last hand position, and later we'll create like a last hand rotation, but let's just do position for now. So here, the current hand position is pretty easy to get. Let's just transform dot position, and then in here we can set the last hand position. So once we grab it, we'll set the last hand position to wherever the hand currently is. And then inside of move, we would do something like grabbable.move, and we would give it the current hand position, the last hand position, and then at the very end, we need to update what the last hand position was to be what the current hand position was from this frame.
Question from Robert. Could you add a lerp to that so that it has a damping / ease in, ease out to smooth it a bit?
Yeah, you definitely could. I mean, we could look into doing that later. It all depends on how you want the force to feel. Like if you want to grab an object and just lock it in place and be able to whip it around like really fast, you probably don't want the lerp. or, I mean, you could go for the lerp. So we can test that out later. Right now, we're not going to do the lerp, but we can try it out. I think one thing that I like about not doing the lerp is that, you know, in a weird way, like it ends up making the object very twitchy. And you would think that that's bad. Like in a lot of situations, it is. You don't want to grab something and have it be twitchy. But when you look at, like, I think Episode 7 is a good example of this. Like when Kylo Ren stops stuff with the Force, it's really awesome how they add in this effect where there's a little bit of a judder. And I actually kind of like that. So we can explore doing the lerp later. But you might find that actually without the lerp, it still feels pretty good to have it twitch a lot. Because we're not grabbing it directly. We're grabbing it with the Force. And, I mean, hypothetically, like, I guess the Force would have some twitchiness to it. Alright, so let's keep going with this. Let's move this thing. So the way that we're going to move it is we're actually going to do a move position on the rigid body. So we access the rigid body using our variable RBody, and the position that what we give this is the new position for the rigid body. So we're going to take its current position and then just apply the direction that the hand has moved to that. So we want to do, if we subtract the last hand position from the current one, we'll get the direction that the hand has moved. Now this isn't going to work perfectly. Now we're going to have to fix this, but I just want to show you it to show that we're making some progress, getting on the right track, and so you can see it incrementally as we build it out. So let me see if there's anything else we need to add. We update the last hand position. Yeah, this should work. So let's go ahead and give it a shot. So there's the cube. You guys see that? You see that as I move my controller, it's moving directly with me based on how my controller is moving. So the problem here is that it's not scaled. So I can't really get this thing to me very easily. I have to grab and pull it multiple times. We don't want to do that. So that's what we're going to fix next. What you can see, though, is that since we're doing things on the rigid body and using its kinematic, we can apply like a sort of throw to this already. And that already feels pretty good. There's one other thing that we want to get rid of, which is that this line sticks around even after we've grabbed the object. So let's fix that first, and then later we'll fix how we scale up the pushes and pulls. So the force of code decomposition was with us earlier. So actually making that line disappear will be pretty easy. Once we do force grab, we just have to call this function that we already created, display line, and we'll give it false and whatever the transform's position is. So let's verify that that works. Got it, and it disappears as soon as I click, and then it appears again once I release and point at the object. So that's done. Let's actually scale this thing up. So this part is going to get pretty weird from the math side. I wonder if we should maybe just take a break before this. How are people feeling in the chat?
I think either way works. We've been talking about, so one thing that I think would be really cool and probably more intuitive is when you, instead of doing the line render, or maybe with the line render, you highlight or outline an object to like say that like you can force grab this or not, which I think would be more intuitive. It's part of this. It's part of VRTK. So maybe we'll get a chance to do that later on. Yeah. But it is kind of tricky to use.
Yeah. So that was definitely something that I thought about, and it works. I mean, have not used a highlight with the force because I've never built a force mechanic before this. Um, but what I like about the line renderer is it's so easy and it fits into already like drawing the debug ray and making sure that it works. So it's good for prototyping and like showing how to do this just really quickly. I think that, if you wanted to build something that was release ready, probably the highlights better. And you also would want to do not like you wouldn't want to do a straight line. Like you would probably want to do some sort of a cone somehow so that the person doesn't need to be exactly pointing to it. Like it'd be awesome if there was a little bit of leniency with where you're aiming. But then the problem becomes if there are multiple objects, how do you cycle between selecting them? So one thing that might be possible is to cast out essentially a cone and detect all of the objects and then maybe use the touchpad to cycle through different ones, and then you can click down on the trigger to select the one that you want. But yeah,
Frank wants to finish the scaling before we go to a break.
Okay, all right, sure. We'll do the scaling then. So let's see. The best way to explain this is that when we're standing in the space right here, we have the controller in front of us, and you should imagine that there's like a sphere around me. There's actually a sphere, like a unit sphere. Well, it wouldn't be a unit sphere because it depends on the length of the controller. But imagine that all of the range that I can put the controller in around me makes this sphere around me. Now that's the first sphere. Imagine that there's a second sphere. That sphere is wherever the object that I'm grabbing is. So as I move up the controller, I want that object to move on its sphere. And as I move the controller in, I want that object to gradually move all the way in too. So that's the way that we're going to be implementing the scaling. We're going to scale up the movement from the controller's sphere to the sphere that the object is going to create around us. So if that doesn't make sense, the code might make it a little bit more clear. The way that we're going to do it is we're going to set the magnitude for the movement, that scaling component, once we grab the object. Because once we grab it, we know where our controller range of motion is, and we also know how far away the object is, and then we can use that to create those two spheres that we're going to be moving around. And it's a lot simpler than it sounds, but it's kind of tough to explain. Maybe I'll bring a whiteboard if people aren't really quite getting the concept. So what we'll do is eventually we want to multiply some like move scale towards this difference between the hand position. So let's create a variable for that. We'll use a float. And we just need to set what that move scale is once we grab the object. So create a function, call it public. You could actually use getters and setters here too if you want. And let's see, so once we grab it, let's set that move scale. And what we'll need is, we already know where the object itself is, but we need to know where the hand is. So we'll pass in the position of this hand transform. So this needs to take a vector 3. We'll call it hand position. So now, to set the scale, we'll just take the magnitudes between where the hand is and the origin, which we'll say is me, and where the object is and the origin, which is still me. So we're having a very user-centric version of the force. We're the center of everything. It doesn't have to be that way, but it feels pretty good to do it that way. So the scale will just be the difference between those two magnitudes. So let's get the magnitude from the object to me. that's just transform that position minus, to get my position, we can just use get the position of the main camera. It's not a perfect approximation of, it's not a perfect measurement, it's more of an approximation, but it does work pretty well because the main camera, it's where my head is, and that's a good way to approximate what the origin would be. So game object, and we can get it by using find object with tag camera. Then we just get transform dot position. Now, if you've never seen this find game object with tag, just as proof that that's there, if you go to the camera rig, look at the head. I think it might be, actually, where is it? Oh, I wonder if this is a different version of the camera rig.
What are you looking for?
Just the something that has the main camera. Oh, it's because my inspector's locked. Tricky inspector. But yeah, if you go to the camera head, you'll see that there's this tag main camera. So when we do a find game object with tag, we'll return that piece right there. So that's the magnitude from the object to me, and then we'll just divide that by the magnitude from the controller to me. And to make this easier, let's just store this origin in a variable. So here we would be dividing by magnitude from the hand position to the origin. And let's see. Getting a, oh, need a semicolon there. So yeah, that's how we're getting the movement scale, and that should work. So we're setting that again as soon as we grab this object. Let's check that out in VR. So there's the object. Now you can see that it moves up and down a lot more easily, and I can wheel it around myself pretty well too. So as I turn, it goes with me. I can throw it a lot more easily, maybe too much more easily, so we might want to dampen that later. But again, what's going on there is that as soon as I click, I'm finding the magnitude from the controller to me, and then modulating how I move based on how far away this cube is. So I think that that's a good place to start. I mean, that's probably one of the trickiest parts of the prototype that we built out today. And again, it's based on the idea of a user-centric force. So we can see that when I pull the controller to me, the object ends up coming all the way up to me. When I push it far out, it gets like scaled more than my controller is moving out. And it's pretty nice because it makes it a lot easier to just drag this object around, not have to keep dragging it. It's just so fun to toss it. So far, I mean, we started off with some basic boilerplate of how do we get access to the tracked object and the controller. You see that in the start function right here. Later, we went into actually raycasting for a grabbable object. The implementation for that is right here. That's basically a straightforward raycast. So we defined the ray that we want and what we're looking for from the hit variable. The part that's a little bit different here is we want to make sure that what we're raycasting has a grab item so that we're detecting something that can actually be moved with the force. And then the last part that we got into is actually clicking the trigger to grab something and moving it around. Again, our method for moving it is we're scaling up the movements of the controller to work on the movement of the object itself. That way we can move the controller just a little bit and get a lot of a movement on the object. So I mean, there are some alternatives that you could do to that. I mean, you could try applying forces instead of actually movements. Like someone mentioned earlier, you can lerp instead of directly setting the position. There's lots of space to try out different things. This is just the one that I like the most, and I thought it's also the fastest just to build out and get an easy prototype going. So we'll jump right back in. Let's make rotations work. So we're going to use a very similar approach that we did with the hand position, but we just don't need to scale it anymore. So let's create what should be our final global variable. This will be a quaternion for the last hand rotation. And we can pretty much mirror what we've already done with the current hand position. So get current hand rotation, and just do transform dot rotation. Once we grab this object, we'll set what the last hand rotation was, and that will just be what the current rotation is in this frame. At the very end, we can update the last hand rotation to be the rotation from the previous frame. And what we need to do is actually provide some support inside of this move to rotate too. So let's toss in the current hand rotation and the last hand rotation. Then let's implement that on the grab item. So here we just added in 2 more arguments. We have 1 quaternion for the current rotation, and then another quaternion for the last rotation. So now we just want to apply the rotation between these 2 quaternions to the object itself. We should be able to do that just using rigid body move rotation. I think we have to give it, oh, the new rotation for this thing. Looks like it wants a quaternion. I wonder if there's anything else we can use. Well, we could definitely set the rotation to be raw, but I bet that there's a way using the quaternion class. Yeah, so we can do from to rotation. So this rotates from a direction to another direction. No, we don't want that. Maybe rotate towards. Yeah, this is a solid one. So this will rotate from one quaternion towards the other quaternion. So we want to rotate from the last hand rotation to the current hand rotation.
Joe's asking, can you talk us through the math on this?
Ooh. Okay,
what
so
is the math? I'm not even
let's see. So, I mean, we could definitely have a conversation about quaternions, but at a high level, all that's going on is that as we tilt our hand one way, we want the exact same tilt to be applied to the object. So that's what we're doing. We have the last rotation of the hand, so maybe that was like this way, and then in the next frame, the current hand rotation would be something like that. And so all we want to do is get that amount of rotation and apply it directly to the object. And that's basically what we're doing in a few, like there's a lot of stuff going on here. So what this rotate towards is doing is it's taking the current or the last and rotating it towards the current, and then we're applying that as the actual rotation on the rigid body itself. So to dive deep into this,
you got it.
we'd have to go into like why quaternions are different than Euler angles, and it's really not that relevant. I think that Unity and just like C#, like it does a good job of making it so that usually you don't have to worry about it. But there's nothing really fancy going on here. Like we're not scaling the same way that we did before, and that's because we don't really need to. Like we don't want to twist a little bit and then have that twist the object more than our hand twisted. But that's a design choice too. I mean, you might get into here, try that, and realize that, you know, maybe you want it to rotate in a different way. So let's try this out. I think that should be everything there. So, oh, looks like I can't pick it up for some reason. I also see that the debug rays are still on this, it looks like. Let me get rid of those. Rigid body, move rotation, left hand, current hand. And we're calling that right here. So everything there looks good.
Joe was just saying, some people hear the word quaternion but don't like map it to like the concept of rotation. So just like hearing that like your end goal is rotating something like helps.
Oh, okay, yeah. So we're definitely trying to rotate this thing. So you can see that it's going to rotate directly as my hand rotates. So the tough part here is that my hand's not rotating perfectly. Like, the human wrist just isn't really built that way, so that can be kind of a problem. But this is where it gets really hard. I mean, how do you want it to rotate? Like, should it be locked to a certain axis? Should it be doing exactly what the hand is doing? I mean, it kind of just depends. But what I like about this is that because of the way that we've scaled, you can bring something up to you very easily. You can push it out very easily. And I like being able to tilt to the side. It feels like that's the most common use case of rotating with the force, and that works pretty well when you're doing it this way. A different approach, I haven't prototyped this, but I guess one thing that you could try is applying like a torque to make it spin if you rotate your hand.
If you just toss it and rotate it, shouldn't it automatically do that?
Yeah. Like that?
Yeah,
it will. So you could definitely
Go
lost
on.
the cube. But yeah, you can toss it to rotate it. Alright, so let's see. Is there anything else left? I mean, that's it for the basic prototype at least. I mean, now we can kind of just have fun with this and add in some different stuff. One thing that we definitely should get in is a ragdoll.
Do it.
So first, just to show how fun this thing could be, let's make sure that both of these have a force grab on them. Even just stacking things is super fun. And then also you can hit things with other objects. Oh, I missed, but there you saw those two colliding with each other. So I really encourage you guys to prototype this out and just mess around with these things. It's really fun. Take this, toss the other ones. This is where, like, Darth Vader would be saying, if you only knew the power of the dark side. Boom, another quote.
Well, but the light side has has the force too.
Yeah, but the dark side's way cooler. Oh. Actually, we could get Abdo's hand models in.
Yeah, do it.
Yeah, let's do that.
I have no idea. I don't know if I saved them, but like you can get them from the past project and add them in.
Yeah, totally. Is the flash? Let's see. Where's the past project?
What did you save this one as? The force. So it's the force test should be on there.
Force test.
Yeah,
right,
you can
can
just
I close this out?
Or you just open it in the file explorer.
Oh, okay.
Let's see. Go to desktop. Scroll down.
So Abdo made some really cool hand models that we can use instead of the controllers. They're kind of Darth Vader-y. So they're pretty awesome. Let's see, where are these things? So we need the textures. And we need the FBX file. Oh, there we go. These two, and we're going to copy it into this project we're working on right now. Hopefully this doesn't crash everything. So it's going to do the import on these. Usually the safer way is to close Unity and do this, but this works too. Alright, so let's add these gloves that he created into our controllers. The gloves have a left and a right. We first need to apply the materials onto these things. So I'm going to lock the inspector up here. Let's see where these textures are. So here's the albedo. Got the height map. Next up, metallic and smoothness. And last, the normal. And now these things are all textured. One last change I'm going to make is actually orienting these so that they work with the controller. So this is the right hand. Let's put this as a child of the right controller. We can check off this model. And we also don't want it to be offset at all. It should just be at 0, 0, 0 on this controller. We can do the same thing with the left hand. I think that we're going to post this on the site so that everyone has access to these, right? Or no?
Yes.
Cool.
That is a plan. I might do it later today.
Yeah, so you guys can join the dark side. Be Darth Vader with these gloves. The last thing I want to do is actually scale them down. My hands are not as big as Abdo made these gloves, so it feels a little bit weird to have giant hands.
Well, I think Darth Vader has giant hands, so it's
Yeah.
appropriate for Darth Vader, maybe not for you.
True. Very true. We gotta check though, how big were his hands?
No.
Those things are huge. I actually have small hands, rough, but the force is with me. Alright, so they're on my hands, but they're not oriented correctly. That's a simple fix. We just need to go into these.
Apparently the Dark Force has giant hands, so you might not actually be part of the Dark Force after all.
Darn. No! I guess Darth Vader is not my father. Oh, boom! Another one.
I was kind of late.
I'm running out.
Just speak like Yoda. Just speak like Yoda for the rest of the stream. I'm sure everyone will
That's
appreciate
so
that.
hard. Okay, so we need to rotate these gloves to be oriented correctly. We just want to rotate them along this red arrow, which is the x-axis. So again, as we always say, RGB to XYZ. That's how I know to put in a 90 there, because I just want it 90 degrees along that red axis, which is the X. Same thing with the other hand. Save that. Jump here, and now these hands are just as we want them. They're floating out in front of us, they're taking up the space of the controller, and we can grab these objects the same way that we did before. God, it just feels so badass.
You know what you need?
What?
I don't know if we can find one right now, but you need a breathing sound.
Oh yeah, that would be so awesome. Because just grabbing it and rotating it and then just like
Whoosh!
throwing it out feels great.
Can we build a wall? Build a wall and like have like a giant explosion.
A wall of what?
Like a wall of these like cubes.
Of these cubes? Okay,
Yeah.
we could do that. Alright, let's see.
Just like one of those things I wish we had the Unity editor, the editor VR for.
Yeah.
Just like probably a 5x5 I think would work.
Yeah, I think so too. Make them closer though.
Yep. Nice. If we had a good skybox, I'd also say we should throw some fog in there. All of the cube.
Dude, I think that these might like crash when they hit each other, but we'll see.
We're about to find out. I don't think so. There's enough space between them.
Empty. Let's just put these all in
Good call.
the wall. Gosh, there's so many. We definitely need to get to the ragdoll too. Oh.
Yeah. I think the goal is throw the ragdoll into this
Into
giant
the
wall.
That's so mean. Poor ragdoll.
Dude, you're the dark side. You
Yeah,
can't. There's
yeah,
no
true.
concept of
Alright, I
mean
take
here.
it back. I take it back.
See, this is why you don't have giant hands.
yeah. I'm being too soft. Alright, hopefully that thing stays up. Oh, nice.
Nice.
Okay, great. Oh, this is gonna feel so satisfying.
Leave.
Oh my gosh, it just looks perfect.
Because it is perfect. Yes. Yes.
Wait, restart it.
Alright.
If you're following along at home, you need to do this.
Alright, 3, 2, 1. Oh, that was
a-
not as exciting. Do it again. That's also not as. There you go.
I can't wait until we have the ragdoll for this.
That's great. I approve.
Oh man, there. That's the power of the force. Okay, let's get working on this
Ragdoll
ragdoll.
should be easy, and then it should just feel
Yeah,
like amazing.
totally. So, let's see. What we used last time actually works really well here too. So, what was it? Space Robot Kyle is something that's already kind of like rigged up in the asset store that we could use. What's popping up in the chat? What are we talking about
What
this
are
week?
we talking about? They were saying you should turn the transparency off
On
for the
the
gloves, or at least Abdo is saying, or sorry, Ghoster is saying you should turn off the transparency.
Okay.
And knock down the metallic a bit.
Let's see. So it's in. Oh, okay. I think I'm turning it down. Oh, wait, no, that's turning it up.
Yeah, we were talking for a bit about like kind of getting started with Unity.
The metallic. He said turn up the metallic?
Turn down.
Oh.
It's kind of weird looking at the
Well,
game.
I mean, I think that the like in Oculus Home, don't they use like transparent hands?
They do. But I think the Force ones.
Well, the mapping I think might be a little bit off.
Wait, what did you change?
I changed the.
Oh, this is what you want. There you go.
Oh yeah, solid. What did you change?
I changed the render mode.
Oh, okay.
I'll
What
show
was
you.
it on?
It was on transparent.
Oh, that's why. Dude, you gotta try this.
Dude, yeah. First do it, and then I'll show you.
Okay.
That just look. It looks like it feels great.
It
Nice.
does.
Yeah. It's. Oh, it already saved it.
Yeah,
it
I
was-
saw it was there.
Yeah.
I just didn't realize that it wasn't transparent.
First, get the ragdoll in.
Yeah, totally. So, let's see, this thing. Yeah, Robot Kyle. Alright, Robot Kyle. You're in for some pain.
So there's this game that came out a while ago called Cell Factor. It was for an old physics card. And so apparently that's what it felt like to actually throw things around there.
What was it called?
Cell Factor Revolution.
Cell Factor Revolution. Alright, let's get this guy
Get him rigged up.
Or
actually just ragdolled
so,
up. 'Cause
yeah,
he's already rigged
ragdoll.
up.
We want to make sure that his arms are in a T position.
Oh, good call.
Yeah, I saw that. I was having problems last time I tried rigging it up. I think that'll do it.
Close enough.
Okay. And then to create the ragdoll, just go to 3D object, select the ragdoll, and now we just have to assign all of his different joints to these different values. So for pelvis, I think we'll do hip.
Yeah.
Or root.
I don't remember. I think
Yeah.
it was hip.
Okay, so we'll try that. Then for left hip, we'll do left thigh joint.
Yeah.
Then he has a left knee. For left foot, we'll do left ankle joint. And this, I mean, it's not a perfect mapping, but it should get the point across. Put his knee into the right knee, then ankle into the right foot. So now arm, can do the shoulder joint.
Yeah.
Then his forearm joint for his elbow. Now the right, oh, what's that? Yeah, right shoulder, and then right forearm for his elbow. Middle spine is one that there's not really a good analogy, yeah, so we'll just put root there. And then I think head can go in head. Look good?
I think so.
I think that's how we did it last time. When I tried it, it was similar to this. If not, we'll just fix it.
We got most of them right except for one, and I can never remember what the right one is.
Let's see. Looks like he's, oh gosh. These aren't all perfect, but we don't need them to be. Let's see what happens if we hit play.
Believe. Let's just fall down. Yeah, that looks right.
Yeah, that'll work. Okay, so what we need to designate is what part of him is going to have the stuff that we grab. Probably makes the most sense to put it on his root. But where is the collider for that? Oh, it's this one. Okay, so it's his body. We'll be grabbing him by his body using the force.
You should actually probably put it straight up on Robot Kyle. Because you're just using rigid body, right?
Well, for the raycast, we need to hit a collider.
Yeah, that'll work.
And then, but we also access the rigid body from that collider, so I'm not sure if it would work if we put it there.
Well, what's gonna, you have to say get component in parent, right?
Yeah.
So like if you hit, for example, that like right ankle, you should just get component, go all the way up. I think it does.
I think you have to tell it to.
Yeah.
I'm gonna put it on this just to get this working, because I think that will.
Oh, you actually only, yeah, you only need it on the root anyways.
Yeah,
right?
Because the rest of this looks like it's just like a mesh renderer, and then this just holds animations, which we're not using. So we can just use it on this, but it looks like he has two overlapping colliders in this like hip region. So let's move this up, and we'll grab him by his body. So the last part, we need to add that he's a grabbable item. I think we can do it now. Can't select them for some reason.
Oh, smack it right in your face.
He's stuck now.
You might be hitting another collider.
Yeah. Let's see. Wonder. It's that one. It's his body.
Or yeah, maybe when he was like on the ground. Let me try lifting him up. Oh, you got him.
His head just like flew out of nowhere.
Ah, come back, head. Oh wait, did I just like
what?
throw him into it?
Yeah.
Whoops.
Alright, restart.
Alright.
I think his head keeps flying off for some reason.
I think you're controlling the head.
Really?
Yeah.
I'm just grabbing him by his body.
Okay.
Oh, there we go. Oh shit. Right. Here we go. What do I do? Throw him into it?
No, like make a giant explosion with him.
How do I? Oh, like drag him?
Yeah, drag him in there.
It doesn't really translate the same.
Oh, that's what's happening. Nice! Dude, this kind of feels like Robo Recall, where it's like, if instead of like the head like just like stretching, if you like broke it off,
yeah,
that would work.
That's the topic of a next stream. How do we get detachable?
Make space Robot Kyle break off joints.
Yeah.
Actually, I think that would be. Let me. Here, can I try something?
Yeah.
All right. So I'm
I also want to throw him into that wall.
Where is the? So I think it's on the. No, it's on the head. Okay. So I think we want the brake force here. What's a good brake force? 100? Yeah, I think 100.
Seems good.
All right, give it a shot. Oh no, already. Oh wait, no. His head. What happened?
Did it already? I mean, he hits the ground, so maybe it came off already.
That looks like it came off, but it's like. That definitely looks like his
it's
head.
rolling at my feet. That's so creepy.
That's great. Something's still attached. I'm not sure where.
That was cool.
Oh, it's just the renderers. But yeah, okay. Maybe 100's too weak. All right, I'll make it a 2,000, which may or may not be enough. But okay, his head is still on. It's gone. His head is gone.
I think that it's like hitting the rest of his body maybe and bouncing off because we're not setting the other colliders to his kinematic. So I could do that once I grab this.
Get rid of them.
This is nice. You want to try it out?
Yes. Wait, I first want to make this infinity and beyond.
What's infinity?
The brake force.
Brake force?
Yeah.
Yeah, I think that it's kind of tricky with him because he has so many colliders on him. Yeah, I could hit play.
Yeah. Oh, whoops. It doesn't feel like a force choke just yet.
Yeah.
But it could.
We would need to like grab him by the head. FusedVR definitely has the Sith Lord cackle. the evil laugh.
See, I'm part of the Dark Force. I think you are part of the Light Force, though.
I don't know.
Or the light side. Whoops. No, come back! No! Oh, man. Yeah. You just need a good environment, and I think this would be solid.
Yeah.
Actually, have you, God, I can't even remember the name of it. There's this, like, factory-looking place in the asset store.
Oh, yeah. I've seen that one. It's a Unity level, right?
Yeah.
Does it have colliders on it already? Because that's the toughest part.
Yeah. I think so.
Oh, it does? We could try to do that. I mean, unless if there's something in the chat that people want to see.
What haven't we done? We haven't done. So we did Ragdoll, which feels great.
Yeah.
We did the force, which feels great.
We could try to do like a quick force push, maybe.
Oh, you want to do the outlining of
an outlining
of the object?
Sure. We would need to get a shader.
Do it in VR2K. VR2K has one.
I've never done it with VR2K.
There's a shader in there, and then apparently when I was talking to Stone Fox, he said there should just be a method to like turn it on or off.
Do we have it?
No.
Is it in the asset store or locally?
Yeah. VR2K.
All right, let's see. Update.
A world sandbox where one can face the consequences of their actions and reset. What's the game?
What?
So Joe mentioned this idea of having a sandbox where you could face the consequences of your actions and then redo it. There's a game just like this, and I'm totally blanking out on the name.
Super Hot?
Well, there's
Robo Recall?
Not a VR game.
Yo, what's going on here? Is this already in our assets? Why does it only say update?
Oh, that's a bug in Unity.
Oh, it's because it might be because we're in play mode. Gosh, and it was green too.
I still fall for it every time.
What? It's still an issue though.
Try closing the asset store and open it. I feel
Unity,
like it's
we love you.
We love you, but we hate you at the same time.
Let's see. Oh, there we go. Import. Let's find where this highlight is. So is it just a toggle, like on a?
So you need to. So according to him, it's like you have to make it an interactable object.
Mm-hmm.
Yeah, just import everything. And then on the interactable object, you should be able to just call something like force turn on highlight or something like that.
Okay. Let's check it out.
I will find the name of this game. Graphics on it look really good also.
Alright, so we got the RTK here. And
Life is Strange, that's what it's called.
Life is Strange?
Yeah.
Let's see. Maybe in pointers? No. Where would this thing be?
So, okay, maybe try an example first. So go to examples and grab, so it's 4 or 5. Just click on one of them to just see the name. Yeah, click that one.
Basic object grabbing.
So hit play just to try it out.
Alright, let's see if this is what we're looking for. Are these the droids we're looking for?
I think the answer is no.
Yeah, probably.
There you go. So one of them has a highlight on it. I don't remember which one.
Nothing has a highlight on this.
No model oh, because it's broken. I don't know.
What about one of the
Why?
other scenes?
No. Well, it's just like quick select. Steam
Oh.
VR. Let's just switch. Yeah, I know. Okay, let's try this map. I don't know why that happens. Like, but it does. All right, it found it.
Yeah, there we go.
And one of them has.
Highlight.
Yeah, there you go.
There we go. That has a highlight.
Yep.
Okay.
So that's the one you want. You can probably use that as an example.
Which one is that? So that's this sphere highlight on touch. Let's check what that thing has. So collider, rigid body, interactable object.
So yeah, and then he has
It's grabbable.
that thing.
Touch highlight color. What else is here? So we need probably a. Oh no, that shader is just for
I think you just need the interactable one, and then you need that prefab, the RTK prefab.
Okay, let's try it out.
And then you just need to call the method on it.
Where is my scene? Force grab. Alright, Robot Kyle. You're gonna be our.
Do it with a
dummy.
cube first. Do it with
Yeah. Actually, I was thinking about that.
I was like,
Much better idea to do it with a cube. Okay. Oh, but I should have checked where the interactable is.
let me just do it on the cube straight up.
It's this interactable object, right?
Yep.
Okay. Touch highlight color. Make it red for the force. Doesn't look like we need any of those. We need to insert that VRTK plugin. Where is that?
I've always just copied it, but maybe it's in prefabs.
Let's see.
Or it was probably up on the top. So click prefabs.
Don't see it there.
Okay.
We can probably find it from
Yeah,
one of
you can
these.
just get it from the example.
Oh gosh, wrong button. Let's copy this over. Now, this cube, if it has this interactable object, we're going to call that highlight. How is it doing it though?
Yeah, just Control F for highlight. which of the many methods does it?
Yeah.
Oh, there, this one.
Toggle highlight. Okay, that's convenient. Public too. Okay, great. So let's see, where do we do this? In the raycast, what we're gonna want to do is we can get rid of this whole display line stuff that we're doing. Actually, let's keep it for now just to make sure that we're pointing at it, but on top of that, we're going to see if this game object has an VRTK interactable object. We're going to get it and toggle that.
Yeah, I think it's just toggle, and then you just have to specify true or false.
Oh, is this namespaced?
Yeah, it's in using VRTK.
Can't access it. I thought it was as simple as that.
Using directive is unnecessary. What?
I might be able to access it by VRTK.
Oh, just specify the name. So VRTK underscore.
Yeah, but it won't autocomplete.
What? Show potential fixes? Nope.
Yeah, definitely don't want to make a class for it.
That's
oh wait,
odd.
maybe I'm spelling it wrong.
No. That's odd. That usually works. Wondering.
We have it in
Yeah, you have
here.
it in here. Could be that Visual Studios. No, it is saving. So I'm like, I'm just surprised it's saying unnecessary.
Yeah.
What are potential fixes there? What?
That's not even useful.
Visual Studios, what are you doing?
Uh,
Is it complaining in Unity?
let's see. Good call. No, it's not. So maybe it's just Visual Studios. Restart it.
Dumb. I don't. Yeah. Sometimes I'm just torn between like MonoDevelop and Visual Studios. It's like everyone tells me like use Visual Studios, and I'm just like, MonoDevelop doesn't have random bugs like this, even though it has its other issues.
Where's this?
Yep.
Okay, yeah, nice. Working now. So if that's true, then what we want to do is we're going to get that component and toggle it on. Then we can call toggle highlight. We want to turn it on in this case.
It's not going to turn off unless you have.
What's
It's
it?
like the raycast. When you're not going to get a raycast otherwise. I think it's fine. Just leave it on. If people want to extend it to turn it off when you don't select it.
Oh, we can turn
fine.
it off when we don't select it. By like this should work. We'd have to do. Ooh,
But yeah, then you're not
it's
hitting
messy.
it.
Yeah, we'd have to store it, and then.
Don't worry about it. Don't worry about it for now.
Second.
Like, make sure this works, because I don't even know if this will work.
Yeah, good call. But we should be able to store it pretty easily. But yeah, let's make sure that it highlights once we hit it. We'll just have to add another global variable. Fun. Yeah, not highlighting. This is this one, I'm pretty sure.
Yeah.
That has it on it, right?
Yeah.
Alone.
Although it disabled. What? Or why is this? What?
What is disabling it?
Oh, this one.
Oh.
I'm not sure why that exists. All right, try it out. Nope.
Is it still disabling it?
No, it's on
It's just
this
not
time.
highlighting now. I wonder if, I mean, it might have to do with this having a material on it.
Maybe? Oh yeah, I think he might want to use a special material. I don't, let's check which material he used first.
He had, I thought that it was just the default green material, but it might actually be something specific on there.
Yeah, he just has a standard one on here.
So let's put a standard.
Or I just like make sure it doesn't, when you highlight, it does something. Nope, it's just standard.
Okay, we can make our cube that way. Because I wonder if, I mean, the standard, oh god, what?
Is there anything on here that causes that to happen? Or maybe we're just calling the wrong method. That could also happen. Let's see.
Anybody in the chat see anything?
We should have done this when Stone Fox was here.
Yeah.
Whoops.
You could script on the object.
Allow both controllers. Allow touched controllers. Is grabbable. Valid.
Is usable and use options?
Let's try it. Let's ignore that. Pointer activates.
Yeah, I guess we need to dive into the toggle highlight to figure out.
Believe.
No.
No, I didn't believe hard enough. Oh wait, no, this is. Oh, this is VRTK. Sorry. Let's. I don't know why this happens. It likes when you toggle it on and off. All right. No.
Maybe this will be.
Oh wait, it's still. No model
objects.
container could be found. Have you selected a valid? I did. I don't know why. Oh, this.
Was it in play mode?
This stuff needs
okay.
to be auto-populated.
Quick select SDK.
And I'm just going to Oculus to switch it. Boom, boom. All right, believe.
Believe in the force. No.
No. Well, there's no
you.
errors, at least.
No.
There are no errors.
What if we just put a default material on this thing?
Like a standard one?
Yeah. Or just add in a cube, I guess.
All right,
Put this.
This is standard. Let's try it. Hey, it's doing something.
Yeah, so that did sort of what we want. But yeah, as you're talking about, now it won't work when we get off. We can fix that.
Most of the time.
Oh no.
Yeah, we're close. We're close to the end. So it should be an easy fix. Hopefully. It's an annoying easy fix.
Jankiest thing is to just store that interactable and then toggle it off, set it to null once we leave the object. So it's kind of hacky, but should work. Set the interactable equal to that, and then oh my gosh,
the autocomplete fails.
do I think that'll do it. Yeah, there we go.
Solid.
So we could just throw that onto all of these too, but
yeah, and
now we could turn off the line renderer also.
So I think the line renderer works nicely though.
Yeah, I like it. I mean, this works too, though. Let's see. So all we have to do is comment out these
Nice.
display lines. Yes, decomposition for the win. Yeah, but you see, like, it is kind of weird, you know, like.
Yeah, I was like, yeah, I kind of like the line.
It works. But this is where, like, the cone would really come in handy, where I don't need to hit it exactly.
Yeah. Get out of here.
Farewell, cube.
Where's? Oh yeah, he's still on the ground. I was like, where did Space Robot Kyle go? This one's gonna be hard. Yeah.
Yeah, it's really hard without having to.
It's kind of crazy, right? Like the line makes so much of a difference.
Yeah.
See ya.
All right, I think that's time.
Yeah. This was fun.
Yeah, I really encourage you guys to jump in there and try it out. Not just because the design is interesting, but because it feels really good too. As we've found before, physics and VR, it just feels great. But this is a cool one because, you know, the Force looks so simple in all of the movies and the concept seems simple, but there's a lot of ways that you can design it. And we didn't even go over how you could potentially use both hands. So there's just a lot that you could really dive into. But hopefully this is a good start if you actually want to flesh something out.
Yeah, absolutely. And so we'll stick around in the chat for a little bit until YouTube decides to boot us. And yeah, that pretty much does it for the stream. I hope you guys enjoyed. If you haven't, definitely leave a like on the video. It helps us out a lot. And subscribe too. That even helps us out even more. And you can also follow us on social. We're putting out a lot of content there. So if you want to keep track of what we're doing over the course of between streams, really, you can follow us there.
Yep.
So with that, this has been Fuse Man.
And Hassan.
And we're signing out.
Keep building great VR, you must.
See you guys later.